In this video, we're going to look at Unit 4, Organic Chemistry. We're going to look at Introduction to Organic Chemistry, which is A, and we're going to look at crude oil and the alkanes. Now, I would recommend to pause the video now and go through each point of the specification and tick whether you feel comfortable with them or not. If you don't feel comfortable with something, I'll just say maybe you just circle it or underline it or something, but I think it's very useful for you to take note. Again, I would pause and just read it. Again, pause, make notes. Do you feel comfortable? And that's the last one, alkanes. It's a shorter one, the alkanes. Okay, first question. Give yourself about 4 or 5 minutes to complete this. I'll pause the video and then play for the answers. Okay, so our question was describe how crude oil is separated into fractions, and first thing you have to say is you need to mention fractionating or fractionating column or something like that. So your first mark would be mentioning fractionating column and then talking about it being vaporized in a fractionating column. So I think that could be your first mark there. Crude oil is vaporized in a fractionating column. It's hot at the top and cool at the bottom. You'll get another mark for this, some idea of there being a temperature gradient. And then your next marks can come from fractions condensed at different levels because they have different boiling points. Now I've put in bold here the key points that you want there for your 4 marks. Next one, state the general formula of the alkanes, CnH2n plus 2. Okay, I'll give you 3 minutes, about 2 or 3 minutes for this. Pause now. Okay, so 2 characteristics of members of the same homologous series or substances in the same homologous series, and that is they have the same or similar chemical properties. Now, chemical properties just meaning how they react. So it's all about the reactions here, and that is how they react, what they react with, so what they react with and what they react to form. So, for example, alkanes, they all react with oxygen in exothermic reactions. So they give us, so that's why they make good fuels. They react with oxygen and lots of heat is released. You could have also had another characteristic of a homologous series. You could have had a change in physical properties, so some type of trend, or pattern in physical properties. So in our alkanes, as alkanes get larger, they get darker. There's a trend, they get darker, they become more viscous. So I'll just put an arrow there, viscous, so they become more viscous. They become less flammable. So there is a pattern here. And that's the same with all homologous series. Or you could have had the same functional group. So all of them have the same functional group. And this functional group is just the group which serves the function. So it's just the part of the molecule which has the biggest function. So in our alkane, it's CH2. In an alkene, it's the double bond. That's where the reaction's happening, or where the biggest, or where the reaction would happen. Another example could be an alcohol. That's where your reaction would happen on the OH group at the end of an alcohol. Okay, and C. Now, when you're balancing out combustions of these exothermic reactions with the hydrocarbons, when you're balancing them, I'd say always balance the carbons first, then the hydrogens, then the O. I call this to remember just CHO. Try to remember that word CHO. But you always balance the atoms which there are less of in the equation. So if this is a problem for you, I'd say go back and maybe have some more practice at just balancing different length hydrocarbons, and just give yourself some different length hydrocarbons like C4, H10. Just give yourself some different alkanes or something. Okay. I'll give you 2 minutes for this. Okay. So identify this gas in incomplete combustion, this poisonous gas, and explain why the gas is poisonous. That's carbon monoxide. And which two elements combine to form nitrogen oxides or oxides of nitrogen? And that's those two. Okay. I'll give you 2 minutes for this. Pause the video now. Okay, so with your isomers, you're looking here for isomers. Here I would say with this molecule, you can just draw the straight chain isomer here. You can just have the straight chains. We've got 1, 2, 3, 4, 5. We've got 5 carbons. You can just have the straight chain one there. That is an isomer. Okay, but you do need to connect all of the hydrogens as well. Then what you can do is just draw out 4, and then you can put the last carbon on an atom in the middle. It can't be at the end. If the other carbon was at either of the ends, then this molecule will be the same as the above molecule. It has to be on one of the middle two. Doesn't matter which one, because it's still the same, because if you flip this molecule around or upside down or whatever, it will be the same, so it doesn't matter. Okay, I'll give you about 3-4 minutes for this. Okay, so you should know the fractions there. And it says state the meaning of hydrocarbons, and that is a molecule or compound which contains carbon and hydrogen and only. You can just write C and H only. Okay, and that will get you the mark. Take 3 minutes on this. Okay, so we're looking at the difference between, describe how the boiling point, colour, and viscosity of the fuel oil. So I'll also say underline, just so you're clear what you're answering, fuel oil differ. So I'll put fuel oil up here. So we have fuel oil because it's lighter, it's smaller. So it's smaller, so I'll put it up there. And then we have gasoline. So yeah, no, sorry, oh, the other way around. Sorry, gasoline, that's lighter than fuel oil at the bottom here. That's larger, and that's what we use for ships. So as we go down, they get larger. The boiling point, so we get an increased in boiling point. That's because we have intermolecular forces increase, and therefore more energy is required to separate the molecules. And then color, it gets darker as we go down because light can't pass through. Light finds it more difficult to pass through. And then viscosity, it becomes more viscous as we go down. That's just because the larger particles, they're harder to move around each other because they're larger. Here are your answers. Take 3 minutes to answer this, or less if you need. Okay, so your catalyst is silica or alumina. You can't say silica oxide. You can't mix both of these names. You can't say silica oxide or alumina oxide because it just doesn't exist, so they'll ignore it. And your next one is you just have to do a bit of maths and minus them, and that you would have got that. It'll take 3 minutes or less to answer these. Okay, so you should have got these. Okay, take 2 minutes or less to answer this. Okay, that could be acid rain, and that acid rain can have an adverse effect on any of these things: plants, fish, or limestone. Take 2 minutes to answer this or less. Okay, isomers, they have the same molecular formula. Let's choose C4H10 because that's the smallest alkane, which shows isomerism, and that has a displayed formula of 4 carbons. So this is the straight chain straight chain butane, and you have all your hydrogens. You will lose a mark sometimes if you don't put your hydrogens. I would recommend to put your hydrogens in. So the same molecular formula, but they have different structural formula. Let's do the structural formula here. CH3, CH2, CH2, there's another CH2, and then there's a CH3 at the end there. Okay, so you have, so that's your structural formula. Now looking at an isomer of this, you can have, let's draw the structural formula, so the displayed formula where you display the bonds. Let's draw it like this. Okay, so we drew one branch, this display formula, and let's draw the structural formula of this. So we have CH, let's see how it differs. We have CH3, we have CH, then we have brackets, CH3, we put that in brackets because it's a branch. I always remember it like brackets, branches in brackets, sorry, branches in brackets for structural formula. So C2, CH3, and then CH3 at the end. And we can see that there are 1, 2, 3, so there's 9 hydrogens there, 10. So there's 10 hydrogens, and there's also 4 carbons, so the molecular formula is the same as well. Okay, take 1 minute or less on this. Okay, the answer is D. That's because when we're trying to find out the isomers here, when we're looking at isomers or trying to name isomers, or we need to find out what the longest unbroken carbon chain length is to find out the root name of that compound. So here for A, we've got 1, 2, 3, 4, 5. We've got 5 carbons in a row there. So there's the root of this name here is pentane. It's going to be like 2,4-dimethyl-pentane. The root name for this one, if we find out the longest unbroken carbon chain here, is 1, 2, 3, 4, 5, 6. The root name here is going to be hexane, and that's just going to be 3-methylhexane. So we've got a methyl group there. And then here, see, we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Sorry, so again, that's going to be hexane. Then here we've actually just got one straight chain, so this is not an isomer of this one at the top here.